Hello everyone. In today's video, I'll cover how following Zscaler data protection best practices, you can significantly reduce false positives. DLP is not a simple undertaking. It requires a comprehensive data protection strategy that is supported by critical stakeholders across different business units. Gaining alignment on use cases, finding tools that address them, and building a team that will shepherd through the implementation and administration of those tools is crucial. But even if you have a strategy and you have brought a DLP solution that supports advanced detection techniques and inspect encrypted traffic, you still need to address the most crucial aspect of a successful DLP implementation, and that is creating policies that supports your goal. Most DLP solutions have pre-configured dictionaries to detect PII data, example credit card numbers. These dictionaries are based on regular expression patterns that may perform checksum validation. So to simply set up a basic rule that scans all outbound traffic across all your users and triggers on any 16-digit pattern that fits the regular expression, right? Unfortunately, all the false positive that you have to weed out will make your head spin. I'll start with a very simple policy that blocks CCN more than 0. So here's the policy that we have, and these are some of the sample files that I'll use for this demo. So try to upload any file, whether it has 2 credit card numbers or more, like 10, everything will be blocked. So there'll be a lot of false positives and no protection. But on the flip side, you have a visibility into the credit card data. To clarify, most false positives are not just the algorithm detecting a series of random 16-digit numbers. They are more likely to be an actual credit card numbers whose use pose no risk to the business in the context they are being used. These could be your employees doing online shopping with a personal credit card or your finance department paying invoices. For DLP admins, such activities are not considered as data loss incidents. To avoid false positives, pre-configured pattern-based dictionaries typically come with parameters for context that can be adjusted based on your use case. If you want to detect the accidental loss for large quantities of credit card numbers, you can adjust the threshold of pattern occurrence that determines when the dictionary will trigger. For example, if you set the threshold to 50, the transaction will be blocked and you will receive the incident notification only if 50 or more pattern that matches the regular expression for credit card are being triggered. For this demo, let's increase the count to 5. So we have the policy here. This is the policy that we had in the previous case. We made it allowed. And then this policy for credit card more than 5 is set to block. So anything less than 5 credit card numbers will be allowed by the second policy. Everything else will be blocked. So if you pick a file with 2 credit card numbers, see that it's allowed. Whereas if I try to upload a file with 10 numbers, it's blocked. Or with 50, could see it's blocked. So some false positives are reduced, but we still have some false negatives. But the positive thing is that we have a reduction in false positive after increasing the block for more than 5 credit cards. If you want to detect the accidental loss for smaller quantities of credit card numbers, you can adjust the amount of context in proximity to the detected pattern, which the DLP system takes into consideration before triggering an incident. There are usually tiered confidence ratings that range from doing a simple run check validation only to additionally checking if the patterns are presented in common formats, all the way to looking for payment card related keywords in proximity. Using these parameters to tweak your policy will significantly increase your detection accuracy without causing false positives that clutter your remediation system. Let's add a high confidence with proximity length 100 with a high confidence phrase. So going back to our policy, you could see that we have this policy which uses this engine. And here is the dictionary that I'm using, which is CCN greater than 5. I have the high confidence threshold set to high with a proximity length of 100. And these are the high confidence phrases. And the last one is the expiration date. Now the sample file that I'll use for this use case is this. You can see that it has this expiration date high confidence phrase. So if I upload this file, since the credit card number is within the proximity length of this high confidence phrase, you see that it triggers the policy and it is blocked. So now let me make a change in this file and upload this file again. So this time, since the high confidence phrase is not matched, the policy will not trigger and the file will not be blocked. So you could see how we can have these high confidence phrases and the proximity length added to the mix to further reduce the false positives. To reduce the false positives even further, we can include the BIN number. BIN number is a 4 to 6 number on a payment card that identifies the financial institution that issues the card. So for this test, I have 2 files and both with 7 credit card numbers. The file with same BIN, as you notice, has the same BIN number started with 455629, whereas this other file with a different BIN has 4 numbers that start with 455629, but other BINs are different. So going back to the policy that we have, which uses this dictionary, if I add a BIN number here, so what it says is that for this dictionary and policy to trigger, we need a file with more than 5 credit card numbers and more than 5 occurrences of this BIN number. So which means that if I upload the file, this file with the same BIN, since it has more than 5 credit cards and more than 5 occurrences of that BIN, this should be blocked. Whereas if I upload the other file, which even though it has more than 5 credit card, but the matching BINs are 4, this should go through. So you could see that how we can even reduce the false positive by including a specific BIN that you are looking for. On the same note, we can have the advanced data classification enabled. I have the same 2 files that I've used for my previous test. In the image format as well, which is the same BIN and this file with a different BIN. So now in this next verification step, let's upload those 2 files, and we should expect the result that with the same BIN it is blocked, whereas if I upload the image file with different bins which has only 4 matching bins, this goes through. So the same check that we have matching and looking for the bin works for image files as well. So that's the advanced classification that I have already enabled. Now as the next step, to further reduce the false positives, let's add a file type. We already have the high confidence phrase, we enabled OCR. So let's add a file type to our DLP policy. So I'm adding the txt file here as my file type. So now what we say that is that look for the files that have more than 5 credit card numbers. Remember, we have that bin check in place, and only look for txt file before this policy is triggered. So let's use that same file that we had in the previous test, that 7cc and same bin. Remember, we need to meet that bin criteria to trigger, but since this is now a txt file and we are looking for a txt files format, so this is blocked. But if I upload a similar file but in a PDF format, since this does not meet the file type criteria, this is allowed. So this further reduces the false positive, even though we still have some that are still there. Now as the next step, let's add the minimum data size, which is the data size that must be met before the DLP policy applies. So for testing purpose, I'll set the minimum data size to 1 KB. So go back to our policy here, and this minimum data size, just for this demo purpose, I'm setting, because my txt files are not too big, so I'm setting a low threshold here. So now I will pick 2 txt file, because remember that we are building on top of the previous additions that we have made. So we are only blocking txt files. So I will upload 2 txt files, one that exceeds this minimum limit and one within. So and we have to match the bin. Remember, we also have the bin criteria enabled. So I'll first upload this file, which is, as you can see, is 433 bytes. So it has 7 credit card numbers. It matches the bin. It also of the txt format that we are looking for, and the minimum criteria file size is 1 KB. So as you can see that this file is through. But if I upload this file, which is a bigger file, and it exceeds that minimum 1 KB limit that we have set, again, it has more than 5 credit cards, all with same bin, txt, this should be blocked. So this is how we have further reduced the false positives. To improve the policy and reduce the false positive even further, let's add an application. So let's edit the policy. We have the file type, we have the minimum data size, and now let's add the application, say Gmail. We already have the bin check in place in our dictionary. So now this file that we have uploaded, which was blocked earlier because it has more than 5 credit card, it matches the bin criteria, it is of txt format, it is more than 1 KB. It was blocked before, but now since I'm looking for the cloud application Gmail, this was blocked before we added the cloud application, but now this time we expect this to be true. Whereas if I go and upload this same file and try to attach in Gmail, as you can see that this time the block is happening matching the cloud application that I have added to my DLP policy. So to recap, what we have covered so far is that we started with a very open policy that looks for any number of credit cards. Then we set the count to 5 so that files with less than 5 credit cards are not blocked. Then we added the high confidence phrase and the proximity len that it looks for. We did a bin check to make sure that only files that are matching with at least 5 bin occurrences are matched and blocked. Then we added OCR. We added the file type that only looks for a certain specific type of files. We use TXT in this case. And then we added the minimum data size. And finally, we added application on top of that. So this is how we have gradually went on in building our policies to significantly reduce the false positives. So in addition to the tuning that we already did, here are some other Zscaler recommendations. Zscaler recommend to disable the URL encoded data inspection. URL encoded data is a 64-bit encoded set of strings. For DLP dictionaries with numbers and alphabets, it will definitely trigger. URL encoded data is no longer a comprehensive means of egressing sensitive data. And if you do a bulk data, it does not make sense to do URL encoded data. By not exempting the URL encoded data, you are likely to get many false positives. Zscaler recommendation is to have it enabled by means of which the content type of URL encoded data will not be subjected to DLP evaluation. You can also exempt certain URLs or user-defined URL categories you want to exempt from DLP evaluation to reduce false positives even further. You can add Boolean logic leveraging ML categorization. By fine-tuning the dictionaries, like I showed by applying minimum file size, apply DLP policies to a set of users and subject dictionary to a specific destination URLs. Then advanced data classification, like I showed OCR. For classification of structured and unstructured data, you can even add EDM and IDM to the mix. So what we want is the DLP engine to only look at stuff that makes sense and every outcome is actionable. The moment there's a lot of noise, the human tendency is to start ignoring. Using these parameters that we covered, you can tweak your policy to significantly increase your detection accuracy without causing false positives that clutter your remediation system. So hope you find the contents presented in this video useful. Feel free to reach out if you have any questions or need help to take advantage of these detection techniques to tune your policies and set your DLP program for success. Thanks and have a great day.